Here we want to graph this function. So this is a polynomial function. Its degree is 3. So what we do, and as we do these, there's sometimes different strategies along the way how to do the different things, but we always want to factor first. So sometimes it's an easy factoring, sometimes you have to use C over D and synthetic division. In this case, it's a very simple factoring. Sometimes it's factoring by grouping, but in this case we can factor out an x squared, and we're left with x minus 1. And we factor to help us find zeros, or x-intercepts. And so we find x-intercepts, the values that make this equal 0. So we actually think 0 equals x squared times x minus 1. So the zeros are at x equals 0 and x equals 1, the values that make this 0. Now, I left a space here because 0 is multiplicity 2 because it has a degree 2. So usually we just put multiplicity 2. And this means when it hits the 0, it's actually going to change direction. So we factor to find our zeros. We also look at our end behavior. You can even talk about end behavior first. End behavior, you look at the leading coefficient and its degree. So let's just quick do a chart just so you remember this. If the leading degree is even, it could be even or odd. So even or odd. And the leading coefficient could be positive or negative. And so if it's even, they're going to go in the same direction. If it's odd, the end behavior is opposite direction, so odd opposite. So if it's positive, they both go up. So up on the left and up on the right. I'm not going to be able to fit all this stuff in here. If it's even and negative, they both go down. So the left is down and the right is down. So when I put this little ordered pair here, it just means the direction on the left and the direction on the right. If it's odd and positive, the left is down and the right is up. And then if it's odd and negative, it's opposite of that. So the left is up and the right is down. And so let's look at ours. Ours, the degree is 3, so that's odd, and it's positive. So the left is going to be down, the right's going to be up. So over here, we're going to think left goes down, right goes up. These aren't definitely where our graph goes, but that's going to remind us we could always erase and move it later. So in this case, we have the down and up. Backing up a little bit, I should have actually marked these. So we have zeros at x equals 0. And at x equals 1. And that's really all we need. We could choose a couple extra points if we wanted to. Sometimes we choose the y-intercept, but we already have the y-intercept, it's 0. So if we wanted to, we could choose like -1. Putting -1 in here or into our factored form, it doesn't matter. So -1 cubed is -1 minus -1 squared. So we have -1 minus 1, because -1 squared is 1, gives us -2. So we have a point at -1, -2. And maybe we come to 2 here, putting in 2. 2 cubed is 8, minus 2 squared is 4, so 8 minus 4 is 4. So we have a point at 2, 4. If we want to see what happens in between these 2 points, we could plug in half, because that's between 0 and 1. 1/2 cubed is 1/8. Minus 1/2 squared is 1/4. And if we get a common denominator of 8, we can multiply this one by 2 over 2. So we have 1/8 minus 2/8 is -1/8. So that's right here. So let's now use the end behavior, the points that we have to graph this. Remember my last graph was pretty rough looking. Hopefully I do a little bit better here. So we're going to come up. This is supposed to be smooth. Now we get to 0. Remember, it bounces off here because we had that multiplicity 2. Comes back down, and then it goes through here, and it can go through our point here, and then up. So a rough start here. But that's about what the graph looks like. All right, moving on to some radicals here. Adding and subtracting radicals. We're going to, in order to add or subtract, we need to have like radicals, which means they all have to be the same root. In this case, they're all square roots, but they need to have a common number under the radical sign. So what we want to do first is simplify our radicals. So 8 is 2 cubed. So we're going to do a little bit of review here. This is 2 cubed minus 3, 20. If you factor that, we get 2 squared times 5. And then 45 is 5 times 9. And 9 is 3 squared. So 3 squared times 5. And if you remember here, we can split it up into perfect squares. So we have a 2 squared. That's 2 2's, and we still need another one. These we can't do anything else with. I'll rewrite it, although we could have started simplifying, but we'll do all the simplifying in the next step. And so what we have here is the square root of 2 squared is 2. So we have 3 times that 2, which is 6. And then we have this root 2 left over. Minus this one comes out. So 3 times 2 is 6 again. Times the square root of 5. And then this one, a 3 comes out. So we have 3 times 3 is 9, root 5. And now only these two are like radicals because they're both root 5s. So we still have a 6 root 2. Can't add that with anything or combine it with anything. And then negative 6 and negative 9 is negative 15. And we still keep the root 5. When adding or subtracting, you don't change the value of the root. Next one, similar idea. We can think of root 45. That's 9 times 5, or 3 squared times 5. Over here, this one's already simplified. We can't simplify the square root of 5 anymore. 18, that is 9 times 2, or 3 squared times 2. Square root of 3 squared is 3, root 5, minus 2 root 5, minus a 3 can come out, so 2 times 3 is 6, root 2. Once again, only 2 of these are like radicals, so we can combine those. Negative 3 and negative 2 is negative 5. Root 5 minus 6 root 2. So that's adding or subtracting radicals. Now we're going to some multiplying. Here we have to distribute. So root 10 can get distributed to both of those. Root 10 times 2 is just 2 root 10. We don't combine them. One's in the radical and one is not. Over here, we got root 10 times root 5, so that's root 50. So we go ahead and multiply first, and then we see if we can simplify. 50 is 5 times 10, and 10 is 2 times 5. And so 10 is just 2 times 5. We can't simplify that at all. But 50, we have a 2 times 5 squared, 2, and then 2 5s, so 5 squared. So we have 2 root 10. The square root of 5 squared, 5 comes out, and we're left with root 2. So that's the answer for that one. Here we can apply FOIL, first, outer, inner, last. So we want to multiply 2 times 1, which is 2. And then we'll go 2 times root 2, which is just 2 root 2. Can't put those together. And now, just so we can see it, we'll multiply this. Root 2 times 1 is just root 2. And then root 2 times root 2, there's a couple different ways you can think of this, but a square root times itself is just the number that's under there, so it's 2. Or you could think, well, root 2 times root 2 is root 4, but the square root of 4 is 2. Either way, you get 2. And now what we do is we just add like terms. So we have a 2, and a 2 is 4. And then adding these two terms together, 2 root 2 plus root 2 is 3 root 2, because this is like an understood 1 root 2. And there's our answer for that. On to division. Now division, what we want to do is we want to see if we can simplify anything first. So we can simplify numbers, numerator and denominator. These are both just one term. There's no plus or minus. So we can think, oh, well, I got a root 3 and a root 27. 3 goes into 3 once. 3 goes into 27 9 times. And so this is really the square root of 1 over 5 times the square root of 9. Well, we know both of these. The square root of 1 is 1. The square root of 9 is 3. So 5 times 3 is 15. So the answer is 15. This question here might be the easiest one on the test, if you realize what's going on here. We just have to worry about, remember, I should have mentioned before, we don't want to leave a radical in the denominator. That's our goal here with division. With just one term here, there's nothing added or subtracted. So square root of 25 we know is 5. And 4 times 5 is 20. And that's it. Some of you might think, hey, can we reduce 5 and 20? We cannot, because 5 doesn't go into 3. It would have to go into each term here, and it does not. And the last one still have to do with division, but now we have 2 terms in the denominator for both of these. The rule is you can't have a radical in the denominator, so what we do is we multiply by a form of 1, and that form of 1 is going to be the conjugate of the denominator, which means we change the sign in the middle. So 2 plus 4 root 3 over 2 plus 4 root 3. So we have something divided by itself, so we're just multiplying by 1. And now up here we distribute. 4 goes to both of those, so that's 8 plus 16 root 3 over, and what we learned about conjugates, when you multiply them, you'll always get the first term squared minus the second term squared. Now, if you forget that, you can always go ahead and FOIL 2 times 2, 2 times 4 root 3, and then multiply the other one. But this will always work when you multiply conjugates. It will be the first part squared minus the second part squared. Still have to be careful with your multiplication here. Here we have 4 minus, when we square something, that means it's multiplied by itself. So really we're going to have a 4 times 4, which is 16, and a root 3 times root 3, which is just 3. So we can simplify that. This is 48. So we have 8 plus 16 root 3 over 4 minus 48, which is negative 44. And now here's where we can simplify, because 4 goes in each of these. So what we can do is we can reduce 4 with each one of these. So 4 goes into 8 twice, 4 goes into 16 4 times, and 4 goes into negative 44 negative 11 times. So the answer is 2 plus 4 root 3 all over negative 11. The next one, it's the same concept as it is as 25, just has a few more radicals in there. So we're going to multiply top and bottom by the conjugate of the denominator, because we cannot keep radicals in the denominator. So that the conjugate is to change this from a plus to a minus. And what we do to the bottom, we're going to do to the top. So we're really just multiplying by a form of 1. And now we have to do FOIL up top. So we have 12 root 3 minus 3 root 2. And then minus 8 root 15. And a negative times a negative is positive, and that's going to be, this last one will be 2 root 10. And then multiplying in the denominator, This is a number times its conjugate, so it's going to be the first thing squared, so 4 root 3 squared minus the second thing squared. So simplifying, there's actually no like radicals in the numerator, so we're going to leave that the same. That happens sometimes. And then in the denominator, this is 4 times 4, which is 16, and root 3 times root 3, which is 3. Over here, this is root 2 squared, which is just 2. And so this is going to be 48. 16 times 3 is 48, minus 2 is 46. And there's our answer for 26.